Hello everyone, welcome. Today we're diving into a key math idea, the function. It's a fundamental concept that underpins much of mathematics and even appears in everyday life. We're going to break down what a function is, how it works, and why it's so important. At its core, a function is simply a rule. Think of it as a set of instructions. This rule takes something called an input and transforms it into exactly one output. It's a relationship, a connection, a transformation from one thing to another. Think of it like this. For every question you get one specific answer. There's no ambiguity, no multiple possibilities. The function provides a clear and defined result. Imagine your birthday. Each person has only one birthday. You might celebrate it with friends and family, but the date itself is unique to you. That's a function. The person is the input, the birthday is the output. The function links you to that special day. If you and your friend both have the same birthday, that's fine. Many different inputs can lead to the same output. But you can't have two birthdays. That would break the rule. One input can only have one output. The heart of a function is this: one input, one output. This is the defining characteristic. Many people can share the same output, but each input gets only one result. This directionality is crucial. This rule makes functions predictable and reliable. We can count on them to behave consistently. If you know the rule and the input, you always know the output. There's no guesswork involved. Functions help us understand and predict relationships in math and life. They provide a framework for analyzing how things connect and change. They're like a promise. Give me an input, and I'll always give you the same output. This consistency is what makes them so useful. This is why functions are so powerful. They are the workhorses of mathematics. They let us see patterns and make predictions. By understanding the function, we can anticipate future outcomes. If you change the input, the output changes in a consistent way. This allows us to model and understand complex systems. That's the magic of functions. They reveal the underlying order in what might seem like chaos. We'll explore more about how these rules work and where we see them next. Get ready to see functions everywhere. Let's keep going. The world of functions awaits. Now let's focus on the two main parts of a function: input and output. The input is what you start with. The output is what you get back. Think of a vending machine. You put in money, input. You get a snack, output. For example, if the rule is add 2, and you put in 3, you get 5. Change the input to 10 and the output is 12. Every input has exactly one output. The output depends completely on the input and the rule. If you know both, you can always find the answer. This predictability is what makes functions so useful. Functions must work for every input they're designed for, not just a few. If the rule is add 2 for all whole numbers, it must work for 0, 1, or any number you choose. The function's power comes from this consistency. For any valid input, you get a single correct output. That's why functions are everywhere in science, finance, and more. They help us study patterns and make reliable predictions. How do we show functions? How can we best represent these relationships between inputs and outputs? There are three common ways to visualize and express functions, each with its own strengths and advantages. First, we have arrow diagrams, then there are tables, and finally, we can use graphs. In an arrow diagram, you list all the possible inputs in one group, and the corresponding outputs in another group, clearly separated. Then you draw arrows from each input to its corresponding output, visually connecting the related values. This makes the function's mapping very clear. For a simple function like add 2, if your inputs are 1, 2, and 3, representing the starting values, the outputs, after applying the rule, are 3, 4, and 5. Crucially, each input points to exactly one output, demonstrating the fundamental property of a function. Tables are another way to represent functions. You create one column for inputs, and another column for the corresponding outputs. For our add 2 example, your table might show 1 maps to 3 or 1, 3, 2 maps to 4 or 2, 4, and 3 maps to 5 or 3, 5. Tables make it easy to spot patterns and quickly understand the function's rule by observing the relationship between the input and output values. The third way to represent a function is with a graph. On a graph, the horizontal x-axis is used to represent the inputs, while the vertical y-axis represents the outputs. Each input-output pair is then represented as a point on the graph. So, for our add 2 function, you'd plot the following points: the point 1, 3, the point 2, 4, and the point 3, 5. Often, when you plot several points, these points form a recognizable pattern, such as a straight line, which can help visualize the function's behavior. Graphs give you a visual sense of how the function behaves, allowing you to quickly understand its properties and predict its outputs for different inputs. These different representations, arrow diagrams, tables, and graphs, all help us see and understand functions quickly and effectively. Whether you choose to use arrow diagrams, tables, or graphs, the underlying goal remains the same: to clearly show the rule that connects inputs to their corresponding outputs. By using these representations, we can effectively communicate and work with functions, making them easier to understand and apply in various contexts. To talk about functions, let's learn some key words. The input is also called the independent variable. The output is the dependent variable. The rule is the instruction that turns input into output, like add 2 or multiply by 3, then subtract 1. We often write rules as equations like y equals x plus 2, where x is input and y is output. The domain is all possible inputs a function can accept. The range is all possible outputs the function can produce. For add 2 with whole numbers, the domain is all whole numbers and the range is all whole numbers 2 or greater. For a birthday function, the domain is all people in your class and the range is all their birthdays. Knowing domain and range helps us understand what a function can do. These words let us describe and analyze functions clearly. Mastering this language is key to working with functions. Let's use these terms as we keep exploring. Let's walk through a function step by step. We'll take a simple example and break it down so you can see exactly how a function works. Understanding this process is key to grasping more complex functions later on. Our rule: multiply the input by 3, then add 1. This is the core of our function, the specific set of instructions that will transform any input we give it. Think of it like a recipe, where the input is an ingredient and the rule is how you prepare it. Try input 2. Let's see what happens when we feed the number 2 into our function. This is where the step-by-step process really comes into play. 2 times 3 equals 6, then 6 plus 1 equals 7. We follow the rule precisely. First, we multiply our input 2 by 3, which gives us 6. Then, we add 1 to that result. Output is 7. So, when we input 2, the function transforms it into 7. This is a clear example of how a function maps an input to a specific output. Try input 5. Now let's try a different input to further illustrate the function's behavior. 5 times 3 equals 15, then 15 plus 1 equals 16. Again, we meticulously follow the rule. We multiply 5 by 3, resulting in 15, and then add 1. Output is 16. With an input of 5, the function consistently produces an output of 16. Make a table. Organizing our inputs and outputs into a table can help us visualize the function's behavior and identify patterns. Inputs 2 and 5, outputs 7 and 16. This table clearly shows the relationship between our chosen inputs and their corresponding outputs, demonstrating the function in action. Each input leads to one output. This is a function. This one-to-one mapping is a defining characteristic of a function. For every input, there is only one possible output. In math notation, y equals sign 3x plus 1. This is a concise way to represent our function, where x represents the input and y represents the output. This formula works for any input. You can plug in any number for x, and the formula will consistently produce a corresponding y value. Try input 0, 0 times 3 equals 0, 0 plus 1 equals 1. Output is 1. Even with 0 as an input, the function follows the rule and produces a predictable output. No matter what input you choose, follow the rule and you get a single, predictable output. This consistency is what makes functions so useful in mathematics and beyond. This step-by-step process is what makes functions reliable. Because the rule is always the same, you can trust that the function will always produce the same output for a given input. You can use the formula to find outputs quickly. Once you understand the function, you can easily calculate outputs for any input without having to go through each step individually. Functions like this are everywhere in math. From simple arithmetic to complex calculus, functions are a fundamental building block of mathematical concepts. They help us model and solve real problems. Functions allow us to represent relationships between different quantities and make predictions about how they will change. Practice with different rules to get comfortable. The more you use functions, the easier they become. Experiment with different inputs and rules to build your understanding and intuition. Let's see how this idea connects to the real world. We'll explore some practical examples of how functions are used in everyday life and in various fields of study. Picture a function as a machine. You put something in, the input. Inside, the machine follows a rule. Out comes the output. For add 2, put in 4, get 6. Put in 100, get 102. The machine is always reliable. Same input, same output. Unlike a gumball machine, which might give you different colors, a function machine is predictable. Every function machine has its own rule. Multiply by 5, square the number, subtract 10, and so on. The key, one input, one output, every time. This machine analogy helps us see the process clearly. Input, rule, output, 3 parts, always in order. That's what makes a function a function. It's a transformation you can trust. Functions aren't just for math class, they're everywhere in life. Earning money at a job is a function, hours worked, input, times pay rate, rule equals money earned, output. Work 5 hours at $10 an hour, you get $50. Temperature conversion is another function. Celsius in, Fahrenheit out, using a specific rule. 0 Celsius is always 32 Fahrenheit. One input, one output. Recipes are functions too. Ingredients in, finished dish out. If a recipe says 2 cups of flour for every cup of sugar, double the sugar and you double the flour. These relationships are predictable and consistent. Functions help us make sense of the world. They show up in cooking, shopping, travel, and more. Whenever you see a clear rule connecting input to output, you're seeing a function. Recognizing these patterns helps you solve problems. Functions are part of daily life, not just math. Start looking for them. You'll be surprised how many you find. Why are functions so important? They're the foundation of higher math and science. Functions let us describe and predict real-world events. Scientists use functions to model growth, motion, and more. In technology, every app and website relies on functions. Programmers use them to process inputs and create outputs. Learning about functions trains your brain to spot patterns and solve problems. It's logical thinking you'll use everywhere, from budgeting to understanding science. Functions aren't just abstract, they're practical tools. They help us understand and shape the world. Mastering functions opens doors in math, science, and beyond. That's why they matter. We've explored the core idea: a function gives one output for every input. This rule makes functions reliable and useful. We saw how to represent functions with arrows, tables, and graphs. We learned key terms like domain and range. The function machine analogy showed us the process, input, rule, output. Real-life examples proved functions are everywhere. Now, look for functions in your daily life. Price lists, recipes, travel distances. Spotting these patterns will strengthen your understanding. Functions are a key to unlocking math and the world. Keep practicing, keep exploring. You now have the tools to see functions all around you.